Okay, so good afternoon, everybody. We're going to be switching gears just a little bit, and instead of talking about solids, we're going to be talking about water. Um, so a little bit of background. I know Ralph just went over this, so I'm going to make it really quick, but just a little bit of background information. Uh, we are looking at PFAS chemicals that have been in production since about the early 1930s, which is their first recorded use by General Motors and DuPont with the use of Freon in their processing. And we are going to be looking at the fate and transport of these chemicals that have been in use since the 1930s. And we are going to be looking at the living filter specifically at the Pennsylvania State University. So, established in the 1960s, this was originally a research project. It was right after about 2 to 3 years of horrible drought. And it was also after an extensive fish kill 5 years earlier that happened due to the thermal shock of disposing of the wastewater into a cold water fishery. So they decided that they were going to look at creating a new way to dispose of all of the wastewater that's been treated. So they created the living filter. It's about 260 hectares of land, and it's approximately 50% crop and 50% forested. So the crops are used to feed all of our dairy cattle and other animals that are within Penn State property. We are a self-sustainable college, so we like to have an area in which we can grow these crops and also have research. So within this land, we are permitted 2 inches of reclaimed wastewater per acre per week. In Pennsylvania. However, we only actually use about 45 to 60% of this permitted value. This is due primarily just because of how much land and how much water is produced, and also how much is actually needed for these crops and land area, because we are a area that gets a lot of rain. Across this research site, we have 14 groundwater monitoring wells, which you can see here on the side. We have all of the dots which correlate with all of the different groundwater monitoring wells. And then we also have 177 lateral pipes with over 3,000 spray heads. We do rotate through which areas are being sprayed. So the entire area is not being sprayed at once. It is rotated to different sections and different areas for through a 10-day rotation. And the spray irrigation of the reclaimed water is to recharge the groundwater aquifers that reside below the living filter. And just to give you a little bit of knowledge about it, the groundwater and soil profile depths reach about 100 to 250 meters below surface level. So it can be as shallow as 100 to as deep as 250 meters, depending on where you are standing within the filter. So a little bit more background on how we designed the testing of this project. We wanted to determine how much PFAS was entering the environment, eventually the livestock, and also in circle with that and entering humans. We do use the milk from the cows to create our very, very famous Penn State ice cream. So we wanted to have a good idea of how much is both getting into the groundwater, which then can be used for drinking water, as well as getting into the crops and livestock. We did use the US EPA set guideline, which is the 70 parts per trillion. Penn State or Pennsylvania is one of the states that does have regulations, but just follows the guideline that the US EPA set, even though technically we don't have to follow anything. And we used the Michigan EPA established guidelines for testing protocol because they were the most detailed, and we figured that that was the best way to kind of go about it, is to have a very established protocol that we would follow. So for our testing, This is actually a picture of the living filter while it is being spray irrigated. This is not one of the groundwater monitoring wells, but it is one of the lateral wells. So you can kind of get a sense of just what it looks like overall. So we did a collection of 1 liter samples from each of the 14 wells in the high density polypropylene, polyethylene plastic bottles. And we also did a collection of the influent and effluent from the Pennsylvania State Wastewater Treatment Plant, as well as collecting field blanks. So every time we went out, we would sample between 3 to 5 wells, and field blanks were collected for atmospheric daily collections. And what we would do was we would just open up a bottle of deionized water next to the well, and if there was any spray that could have gotten into it or anything in the air, we just wanted to see if it was absorbed into the field blanks for those days. The influent and effluent samples that were collected were over a 24-hour composite sample. We did make sure that all of the collection material that was used was either HDPE or stainless steel. We wanted to make sure that there was no cross-contamination with Teflon lined tubes or any other kind of previously used monitoring equipment. We wanted to make sure that this was as clean and as PFAS free as possible. We also, in addition to all of the water samples that were collected 3 different crop samples. We have an irrigated corn, a non-irrigated corn, and an irrigated fescue. We did not collect a non-irrigated fescue because, unfortunately, there was no non-irrigated fescue plot. And the closest that we could find was not within the scope of our area, and it would not be under the same conditions. So we are just looking at irrigated fescue. These crops were dried and ground, and they were sent out for lab analysis. Penn State was not set up to sample for PFAS within all of our samples that we had. So we did send them to an external lab, Eurofins Laboratories in Lancaster, PA, and they did all of the sample processing for us. So unfortunately, we didn't actually get notice that we could talk about the actual numbers that we've kind of accumulated throughout the time that we've been doing this project. We only just got notified yesterday by the Penn State legal team that I could share values, but it was too late by that point. So I'm just going to kind of talk about the 24 different analyzed compounds that we have and the preliminary data that we found with it. So while looking at it, we kind of wanted to look at both the older and then the newer chains. We were specifically interested in PFOA, PFOS, which are the old compounds, and are leading the charge on how to determine the levels for if it's safe or not. And we wanted to also give a kind of deep dive into the PFHXA and PFBA chains, because we have been seeing that they are coming up on the health screens a lot more. They're the newer chains that are making their way through and are probably going to be the next legacy chemicals, so to speak. And so we wanted to focus our particular attention on these because these are being seen in both the crop and the water samples. So preliminary results, what we kind of saw was that the newer chains, such as the PFHXA and the PFBA, like I said, these were found in high concentrations higher concentrations within the wastewater, in the influence and the effluent samples that we found. And they were found in the groundwater wells. However, they were at very low concentrations in the groundwater wells. Compared to that of the legacy chemicals, such as PFOS and PFOA, which were not seen so much in the wastewater treatment plant. In fact, they were almost non-existent in some months. But they were found in higher levels in the groundwater wells. For the plant tissues, we did find that they have the PFBA and the PFOS chains that were found in the fescue and the corn, but we didn't find any other chains in there. We don't know if it's just because of how it's been applied or just how it was laying in the surface, but we did see that they were being picked up, so we wanted to look into that a little bit more. And it was interesting that it was both an old and a new chain that were found in the crops. Overall, we didn't really see much in a change in both the temporal and the spatial trends that were looked at. It's been fairly consistent throughout all. And we don't really see much of a variation either from when students are on campus versus when students are not on campus, which you would think would have an impact on it, but we really didn't see much of a change. So I have a map here that shows just a little bit of the amounts that we found in the groundwater wells. So I wanted to point out that the water direction does move in the direction, the groundwater flow does move in the direction that the wells do increase. So the outside wells that are either non-irrigated or slightly irrigated that do have the lower concentrations are at the top of the groundwater area that it would run down to versus the areas that have the higher concentrations. This is looking at the total PFAS, not just the PFOA and PFOS. This is looking at all 24 PFAS chemicals all added together. And the highest level that we actually hit was about 115 for all of them added together. But when you actually look at what would consider the amounts for PFOA and PFOS just added together, I think the highest we hit was about 33 ppt. So it's still about half of what the monitoring value would be considered advisory. Okay. And that's about it. Thank you. Any questions?
Yeah, so we do have time for questions. Lee, have any questions come in?
Not yet.
While we're waiting, maybe I'll ask one. What do you think the PFAS concentrations are correlated to if they're not correlated to students coming and going?
I would assume that it's just related to how much has actually accumulated in the area. From the 1960s, we have been land-based applying all of the water since 1983. So anything that has come through the wastewater treatment plant would be in that area. There is another student who is doing soil column experiments, and we can see that it's being collected in the soil as well, but it doesn't necessarily leave the area. Like, it doesn't travel very far, and it doesn't get to travel very far. So I think that it's just coming from Teflon lined pans that are used in the dining halls, waterproof textiles that are used out in the dairy operations, and Teflon lined tubing in the wastewater treatment plant. So we haven't seen any spikes. We haven't seen many changes. It's been pretty consistent.